All right. Hello there, all. This is 6.4 notes. Now, this is factoring polynomials. Now, basically what you've known about factoring in the past is still true. All right. A lot of what we know about GCF and difference of two squares and old school factoring and Batman, all that stuff's still going to be with us and it's still going to be in here. We're basically taking factoring to a whole nother level. All right. We're bringing the noise and we're graduating in the factoring world, pretty much. So the first thing we're going to start with is difference of two cubes. So by cubes, I mean cubic function. All right. In the past, we've only dealt with factoring quadratics. Now we're messing with cubes. Now, they're going to come in the form of a to the third minus b to the third. This is a general form. However, it's very, very important to recognize and to memorize, to know, because this is how what we have to use to follow in order to complete this process. All right. So what we do is we take a minus b. So whatever that term is to the third power. So for instance, if it was 8, that would be 2 to the third. A would equal 2. And we'll get more into that in a second here. And we're going to multiply that by a squared plus ab plus b squared. All right, so let's say an example might look something like this. It's going to say x to the third minus 8. Now, the first thing I like to do is determine what a and b would equal. Well, a to the third, so a would be x, and b to the third equals 8. So what to the third power equals 8? Well, that would be 2. 2 to the third equals 8. All right, so that gives me b to be, I'm going to write next to it here. So b is 2. All right, everybody with me? Okay, so now what we do is we take a minus b, so x minus 2, because a is x, b is 2, and we're going to multiply that by a squared, so x squared, plus a times b, so x times 2 is 2x, plus b squared, which is 4. And that's in factored form. Now, one of the tricky things that you have to know is, notice how this is minus. Well, that's fine, because it's a difference of two cubes. Minus minus is easy to recognize. However, this piece is always going to be plus. All right, and that's a little hard to stick in your mind. Now, there's really I don't have an easy, short way to do this. We must follow this here. All right, that's our form that we need to follow. Those are our guidelines. Now, if you're ever confused, though, the great thing is you can always check. All right, so just multiply this polynomial here back out. So I got x to the third plus 2x squared plus 4x minus 2x squared minus 4x minus 8. So notice, because this minus and plus here, 2x squared minus 2x squared, 4x minus 4x, I'm left with x to the third minus 8, which matches my original problem. So those two are equivalent. So it's a little tricky to get the hang of, but once you do it, the good thing is you can always check. All right, so there's no reason why you should get any of these answers wrong. All right, so that's difference of two cubes. Now let's look at the sum of two cubes. Sum of two cubes. All right, so here we have a to the third plus b to the third. And then my general form is a plus b, again, plus plus, times the quantity a squared minus ab plus b squared. So you see the differences. Here it's minus because difference. Here it's plus because of sum. And then it's the opposite on the inside here. All right, so that it allows these middle terms to cancel out. All right, so let's try this one. Let's go 8x cubed plus 27. So again, I like to identify, what does a and b equal? Well, 8 cubed would be 2 cubed is equal to 8. X cubed is x. All right, so I pretty much took the third root of that. All right, then here, what raised to the third power equals 27? Well, b is 3. And I know you wanted to say 9, but that's 9 times 3 is 27. Think of it. 3 to the third is 3 times 3 times 3, which is 9 times 3, which is 27. So you got to think to the third power. All right, then just put it in our general form. 2x plus 3 times a squared. Now, 2x squared, you got to take the squared to both terms. So it's 4x squared minus a times b. So 2x times 3 is 6x plus b squared. So plus 3 squared is plus 9. All right, again, I'm not sure if I followed the correct form. Well, multiply it out and check. 2x times 4x squared is 8x to the third minus 12x plus 18x plus 12x squared minus 18x plus 27. 12x squared, sorry. It's my fault. That should be 12x squared. Negative 12x squared plus 12x squared is gone. 18x minus 18x. You're left with 8x to the third plus 27. Alright, so that's the sum of two cubes. And then the last one is factoring by grouping. Alright, factoring by grouping. Now, the past two were binomials, right? They only had two terms. With grouping, you're going to have four terms. So, for instance, x to the third minus 2x squared minus 9x plus 18. So it's easy to tell when you do grouping. So the first thing when factoring, again, we always look for a GCF. And I'm going to stress that a lot tomorrow when we do some more difficult examples. But we always look for a GCF first. In this case, there's not one. All right, especially because there's no x on this last term. That may happen often. So what we do is we group the first two terms together and the second two terms together. All right, so just looking at these two terms, factor. Well, first thing I always look for is GCF, and here, x squared is my GCF, because I can take two x's out of both, so I'm left with x minus 2. Over here, my GCF is minus 9, and I'm left with x minus 2. Now, notice, this is a lot like the last step of Batman. These two terms are always going to match. And so when we write this in factored form, we get x squared minus 9 times x minus 2. Now, are we done factoring? Well, you need to look at these two terms. Can either of these be broken down further? Well, if you notice, this is a difference of two squares. All right, so back from the chapter before, x minus 3, x plus 3, and the x minus 2 stays. And now I am in factored form. And that'll happen a lot with grouping. All right, you realize you factored, and then you still have to factor more. All right, so let's summarize this. So I pretty much taught you 3 more types of factoring on top of all the factoring we've already had. All right, so to generalize this, please keep in mind, we always, when factoring, all right, so I'm going to summarize everything. When factoring, we always do GCF first. That's the first thing we always look for, GCF first. All right, now, then we got to take a look at how many terms we have. In the event we have 4 terms. All right, so just like the one we just did. 1, 2, 3, 4 terms. 4 things being added or multiplied. 4 things being added or subtracted within a whole polynomial. Whenever we have 4 terms, we're going to look at grouping. All right, factoring by grouping. Now, when we have 3 terms, we're typically dealing with the quadratic. So we always look for GCF first, and then we look at old school factoring. All right, so that's 2 numbers that multiply to this, add to that. Similar to what you did all in geometry and what we've been doing all this year. And then if that doesn't work, we resort to Batman. Before, Batman was our last resort. Now we got a lot more. Now, if we're talking about two terms, right, we have a difference of cubes, which we did in the first example. We have sum of cubes, which we did in the second example. And then we have difference of two squares, which we did in previous chapters, and we kind of just reviewed in that last grouping problem there too, because we had to take it a step further. So now we actually have 1, 2, 3, 4, 5, 6 different ways of factoring. All right, not to mention GCF, which pretty much is involved in every problem here moving forward. So tomorrow in class, we're going to do 3 more difficult examples together. All right, that would be Monday in class. And then Tuesday in class, we're either going to take it further, throw in some ZPP, and some other more difficult things to get some real and imaginary solutions out of these things. So we got a lot of fun ahead of us. So hope you did well on your quiz today, and I'll see you Monday.